All right, in this video, we're going to start working with recommender systems. So I've started by bringing in the movie ratings data set that's available in the sample data. So if you go under components, sample data, you'll see there are a bunch of sample data sets already out there. So I just brought in the movie ratings one here. And if we just take a quick look at it, we can see that we just bring in 4 columns of data. We've got the user ID, the movie ID, so the user ID, the item ID, and then we've got a rating on a numeric scale. And this is your typical setup for a recommender, what we call the recommender triplet. So all of the recommender trainers and scorers require that triplet: user ID, item ID, or in this case, movie ID, and then the actual rating itself. So the timestamp here is an extraneous field. It might be useful in some other methods that we use, but for the recommender algorithms, we can just use the triplet, so we could even use the select columns to get rid of it. All right, so our next thing we want to do is we want to remove duplicates. And in this case, I just want to make sure we don't have duplicates of the same user and same movie. So we'll go to the parameters, edit the column, and because this is the first one right after, I think I'll be able to pick them. Yeah, user ID, movie ID. If we have any duplicates, we want to get rid of those, but we will keep the first instance of duplicate values. So you have the option of keeping the first one or just getting rid of all duplicates. We'll go ahead and keep the one we have. Now, I don't know that we have any, but that's not a bad step to put in. So we can double check 227,472 rows in this data set. Next thing I might do would be to select columns. All right, so selecting the columns in the data set, if we go back to the movie ratings, we've got user ID, capital I, movie ID, capital I, rating, and then timestamp. So we could exclude timestamp, which would be the easiest, I guess, or we could be more proactive and include the 3 that we want: movie, user ID, movie ID, rating. This is another opportunity to change the order . So if I turn this switch on, it makes sure that no matter what order the columns come into my select columns, I can make sure that they go out in the order I specify. So if I say user ID, movie ID, and rating, now they will definitely come out in that order, as long as I have that one setting set to allow the duplicates and preserve the column order in the selection. Of course, I've already gotten rid of duplicates in the step above, so I should not have any duplicates in my select columns. All right, so at this point, I'm ready to split the data. What I want to do is our normal train data and then test with some holdout. And we could go with the sample split here. So I'll bring that in here and we'll do a 50-50 split in this case. So 50-50 split rows, randomized, random seed, and we can leave it as is. So all the defaults. So at this point, I can go back to my components, and you'll see I have a set of components here for recommendations. And you can see I have an evaluate the recommender. And then I've got two different types. I've got an SVD recommender and a score SVD recommender. Then I also have a train and score for the wide and deep. Because we're talking about collaboration filtering now, we'll start with the SVD recommender, which only does collaboration filtering. So if we click on that, we can see we have, well, how many factors do we want to include? How many different recommendation algorithm iterations do we want to run through? Again, so you can fine tune the model by going through more and more. And how big step do we want to take in our learning rate? The bigger the step, the faster we may converge, but we also may overshoot. So that number of factors it's going to create some latent factors, a lot like the LDA we created when we were doing our text analysis. So you can set it to as many or as few. The more factors you end up having in here, the greater the possibility of overtraining. But this is generally not an issue for large companies with a large number of items, something like Amazon. This would not be something to worry about. All right, so 200 would be right there, would be fine. We're going to give it 30 iterations. Again, we can just leave the defaults here. So the user item, so here it even says the training data set of the user item rating triple. So I'll connect our first 50% split there. And at that point, we've got trained recommendations, so I can just bring in the score SVD recommender. So I've got my train model coming in here, my train recommender, and then I'll just take the holdout data and see how it does. That gives me a scored data set, which allows me then to run the evaluate recommender. All right. So when I score, I've got some options here. I can score for item recommendations. So let's say they're looking at a particular item or a particular user. We can just recommend some items to that user. All right. And when we're building the model, we want to do it from rated items. When we put the model into use, we want it to be able to work with unrated items. So we would then change that to unrated items, and it can take information on items that have come in to just sort of provide some basic suggestions. I also have the option of creating rating predictions. We'll take a look at that in a little bit, but let's stick with the item recommendations first and see what we come up with. So from rated items, this is going to allow us to evaluate the model. And remember, after we've done that, we would switch this to unrated items so that we can use it in production when we get new items in. All right, so we can go ahead and run this. Oops, and I connected this wrong. What I want to do is I want to bring the scored data set into the scored data set. And then I'll bring the holdout data into that test data set. So we'll see how it does. Okay. And yeah, we'll call this recommender movies. I'll submit it. And our job is running, so I can now flip over to my jobs and see what we end up with. All right, so we have removed our dupes. Let's see what we ended up with. Yeah, 227, 472, so I don't think we did have any dupes, but it's a pretty good step to add in there just to play it safe. Uh-oh. User ID, movie ID, rating. Oh, I capitalized both ID for user ID and movie ID. whereas I think the D is a lowercase. Yeah, so I'll just have to go back and fix that. And run it again. And we can now look at our new job. Okay, we're moving ahead with the select columns. And we'll come back when this job is finished. All right, so our pipeline has finished running. Let's see what we get in the train SVD. Yeah, and we just get a bunch of files. We can actually look at these. We'll have some Python code and some JSON code that we can look at in the recommender. So the recommender, if we score the recommender, we can now look and see what we've got. And so we see for this user, these are the first, we just left the recommender at 5 items that we recommend for that user. And we only recommend items that we feel confident about. So you can see here for user number 10006, we only recommend 2 items. All right. So that if we go back to the parameters for the SVD recommender, we said item recommendation from rated items for the model evaluation, and we're going to have a maximum of 5. Okay. We did not tell it to return the predicted rating. That was something we could turn on, which would also be interesting. So that we might run that once just when we do one more thing with this. So we evaluate the recommender and we get a preview data and we get a single metric here. It's called NDCG, normalized discounted cumulative gain. So we could think of that as more or less analogous to the R-squared value. So that's a pretty good score. Let's try one more thing with this that can help. So what we'll do is we'll go back to design and we're going to score this, and we'll go ahead and say, yeah, let's go ahead and return the predicted rating as well. All right. So we've used our train SVD, our SVD recommender, single value decomposition. And that's a pretty common one. It's a collaborative filtering approach. Another recommender that comes with Azure ML is called wide and deep. This is one that Google put together, and it's used pretty widely as well. And it can also be used as a collaborative filtering approach. But we'll see that it can also be used for a lot more. So we'll first bring in the training data set, just like we did for train SVD. So we can use it more or less the exact same way we did SVD. So I'll bring in my data set to score, bring in the train model there, scored data set right here. So everything we pretty much can set up just like we did with SVD. Now, we talked about trying to get the names back in here, so I'll see if we can do that with the scored SVD recommender. So if we recall that from the scored SVD recommender, we ended up with 5 recommenders, rated item 1, 2, 3, 4, and 5. All right, rated item 1, 2, 3, 4, and 5. So what we could do is we can go and bring in the data set. I'm sorry, under components, it's not under data. We have some sample data that we brought in for the movie ratings way up here at the top. Well, right near there in this sample data, we've got one called IMDb movie titles. All right. So if we were to bring that in, I can now apply a SQL transformation. And I'll bring my scored results into T1 and my movie titles into T2. And let's just see if we can remember what the scored results are. So user, rated item 1, 2, 3, 4, and 5. All right. So that's one thing. The recommender actually creates its own set of column names when it comes out, regardless of what you feed in. So instead of user ID, it's just user. And then instead of movie ID, it's item. All right. So for the SQL transformation, we'll do a select user from T1, and then it's rated item 1, 2, 3, 4, and 5. And let's just double check. Yeah, there's a space there. All right, so that's what we would get if we just did it from T1. Let's see if we can do a join T2 on T1 rated item 1 equals T2. I believe it's called movie ID in that table. So we can save. And we'll call this movie name, or movie title, I believe. All right, so movie title as movie 1. So let's save that and see what we've got here in the preview data. Not movie name. Okay, so we go back here. Movie name as movie 1. And I believe it is movie ID still. Yeah, movie ID. All right, so we've got ourselves a new model. And then what I could do is I could basically copy this down here. And then do kind of the same thing. Oops, shouldn't have done that. All right, so what we're going to do here is we will now substitute that over here. So now I have user movie 1 from above, now movie name as movie 2, and then I can continue with that approach. So let's run this, see what we end up with. Okay, we're on our last apply SQL transformation. So we can see the score wide and deep and preview the data. Let's go see the score SVD and preview that data as well. All right, so user 10,000, the SVD recommended 1454468 first. And we can see here that the first one for the scored was 2545118. And the prediction would be 8. So 1454468 is the second one. So they switched the first and second recommendations. And then we can see rated item number 313131104 is the same, 1014726, and the predicted rating is slightly different, nothing for rated item number 5. And then we can go down. So you can see that the recommendations vary a little bit. And if we look at our two techniques, SVD gives us a metric of 9.958024, wide and deep 0.961918. So, you know, using this approach, wide and deep, appears to do a little bit better. And it has become more or less the method of choice for a lot of this type of work. All right. So we did the apply SQL transformations, and you can see what comes out. We only did the first two, but instead of a movie item code, we get the actual name of the movie. Movie 1 is Gravity, movie 2 is Blackfish. So using the other technique, it would have been Blackfish and then Gravity. I did forget to include the movie ratings in with this, but I could go ahead and tweak that query and put them right back in. So I would want to make sure that I updated the query to include movie 1, predicted rating 1, movie 2, predicted rating 2, etc., etc. So that gives you an idea of how to use collaborative filtering using the recommender pills available in Azure ML. Let's get back to the reading and see what we'd like to do next.